All right. So now that we have the process, the next thing we are going to do is calculate metrics. There are two types of metrics. There are measures and there are dimensions. Where are my dimensions? My dimensions are up here. You can see out of the gate, PPM comes with a bunch of standard dimensions. So for instance, we have a time dimension that always works. And we also have standard dimensions like number of processes, number of functions, or the process cycle time. We want to now calculate some things that we don't have yet. I want to calculate a flag or a text dimension, which is going to just let me know whether this process has been changed, whether an order has been changed. So I simply want to know if any one of these functions has been changed. I want to basically be able to have a flag about that. That's number one. The other thing I want to calculate is how many changes there are within one process. It could be one of the activities that has a change document attached with it, or none, or several. The way we see this is we have in these events, we have these change documents attached. So if we have these change document information within these steps, then we know there is a change. And if there is no change document within a step, then we know there is no change. So we're going to use this information to do our calculation. Let's go into the CTK and see how we can do this. Anytime we want to calculate a measure, we need to go into this measures and dimension module. Now in here we have a couple of things. The key thing is here the measure and the dimension. Now there's different types of dimensions. So we have here single level dimensions, we have two-level dimensions, multi-level dimension, floating dimension, time dimension, search dimension, and time range dimension. So it depends on what type of data type we have, what kind of dimension we can choose. Most of the time, dimensions are text value, such as what color is your car? And then color would be a dimension, and then green, red, yellow, that would be the dimension value. That would usually be single level dimensions. So probably 90% of all the dimensions that we create are usually single level dimension. A multi-level dimension would be a dimension that has a hierarchy. So for instance, think about a location could have a hierarchy. You could have a country on a high level of a location, and then a state, and then a city, and so on and so forth. So you could have several levels of a dimension. The key thing about a dimension is always that all a dimension basically is a selection of a attribute. So we need to have an attribute in order to create a dimension. The same is true for a measure, only that measures are usually only numerical values. A measure is something you need to be able to do math with. And just like with the dimensions, all you really do when creating a measure is you pick an attribute and use that attribute as a measure. So both in dimensions, all we got to do is we need to take an attribute and then just define this attribute will be a dimension or this attribute will be a measure, and then we can use that. So now the only thing that we have actually missing to create these custom dimensions are the attributes. So in order to create an attribute that does not exist and that we want to create through a calculation, we have here the calculated attributes. And a calculated attributes allows us to calculate a value over here in this calculation rule and write it into a PPM attribute. And so this is exactly what we're going to do. And so let's get going right away. So what I want to do, I want to create a truly new attribute. So instead of using an existing attribute, I'm going to create a new attribute. I can do this here, and I can give this guy a technical name and a descriptive name. So I want to call this attribute number of changes. And I'm going to basically create a counter for every change that happens on a function step. So because of this, I'm going to make this a double. So that means a floating point number. And so here I give this guy an English name and I make sure that I have the right data type set. So now I'm going to calculate this rule that I want to create. I'm going to write in onto each function that is a change function, I'm just going to write the number 1. So what we need to do here, we need to have an if statement. We're going to basically check whether a function is a change function or not. There's a very simple way to do this. We can check whether a change document attribute exists. So I'm going to look for a change document. Here we have these change document keys or change document activity ID. And if this exists, we know we have a change that has happened. So I'm going to look for this on every single function. So what happens here, these calculation rules, they get executed for every activity if I say that the calculated attribute is a function calculated attribute. So what basically CTK does, it goes through every function and it executes this calculation rule. So what I'm going to tell PPM is that when you execute this calculation rule for a particular function, only look on attributes that exist within the particular function that you're calculating this calculation rule for. So when I say on current object, then that means that we're only looking at the attributes that are on the function that we're doing this calculation for. And so basically, I know that if on the function that we're doing the calculation for right now, a change document activity ID exists, then I know that there's a change, there has been a change for this particular activity. And then because of this, I can write into the then clause a simple value of 1. And so this is now an if statement that checks on a particular function if there is a change attribute, which means that there has been a change to this particular activity. And if that is true, then we will create an attribute value of 1 and write it into the attribute number of changes. If this attribute does not exist, we're not going to do anything. We're just going to stop and nothing will happen. So in other words, we will only write that attribute if the function has had a change document that is attached to it. And one other thing that is really important to change here is that we change the node type from process to func, because only then will this be calculated for every single function, and this also determines where the attribute is written to. So we need to make sure that this attribute gets written onto an actual function, which is why this node type must be ot_func. Another thing that is really important here is that we don't have a default value. So let's get rid of this, and this will then make sure that only the functions that actually have a change will have an attribute written into them. We have now created an attribute number of changes, and I can see that I've made a mistake here in calling it number if changes. That is of course annoying, but the good news is that we can change it, and I can use this little mistake of mine to show you how to manage your attributes. Anytime an attribute gets created, and so far we have done this both through this calculated attribute wizard here, as well as through the mapping, any one of these new attributes that we have created, they will appear here in this list of the attributes. So this is basically a definition of an attribute. And then in the calculation or the mapping, this is where actual values get written into these attributes. So this is sort of like, if you think about programming language, this is sort of like the definition of an attribute. And then the instantiation, this would be the line of code where you have the equal sign in it. So here, I should now find my number if change attribute, and I can clean this up. This is another attribute that is just something that should not be here. So I'm just going to get rid of it. And so here I can just change it number into number of changes. And so here I can easily change it into number of changes. All right, so that's it. And let's go back to our definition here of the measures. I now have this particular attribute here, number of changes. And I can still not use this really well for my dimension, because for my dimension, I want to have this flag if there is a change. I'm going to define a flag on the particular function, whether the function is a change function. And so the way I'm going to do this, I'm going to define another new attribute. Actually, I'm going to call it isChange. We have several choices. We could use a Boolean value here, but I prefer to use a text value. The reason why I prefer a text value is simply it's easier for end users to interpret. Some people are just not very happy with interpreting a yes or no or true or false. So I'm just going to write nice little English text into these values. And of course, this also needs to be defined of the function, because we're going to define this for every single function. And so here I'm going to do the same thing. I'm going to say if, and then I'm going to look for our change attribute. And so I'm going to look for a number of changes on myself, again, on current object. And I know this only exists if there is an actual change. So because of this, I can say, in the true case, in the then case, I can say this is a change function. Oops. This is a change function. And else, I can say no change. So now we're going to write either change function or no change function onto the actual function, depending on whether we have these change document information on the function. Okay, well, I can now create a dimension on the function, but I really want the dimension on the process level. So what I'm going to do now, I'm going to define yet another attribute, and I'm actually going to use the absolute same attribute, but this time I'm going to define it on the process level. And on the process level, again, I'm going to look for an if, and I'm going to say exist again. I'm going to look for the existence of a change function. So the way I'm going to do this is I'm simply going to look for my attribute that is change, and I'm going to look on this only on my functions. But now I'm going to look for some with a certain value. So I'm going to throw my equal on top of it. And this is like defining a where clause. So now I'm going to say that, and here I'm using a filtered attribute to say the equal. So equal means I compare two string values and I look if they're the same. And so there we need to use a filtered attribute. A filtered attribute is not a set of attributes, but exactly one. So this is just the technical difference, but technically an attribute is always a set of attributes, could be several attributes technically, even though practically if we look on one function, we know there's only one. So, but here in order to have exactly one value, we need to use a filtered attribute that basically would pick one out of a set of values. And so here I'm going to look for isChange again. And because we're on the same, we can just say on current object, and then it doesn't matter which one it is because we know there's only one. So I can just say this. And now this must be the same as the value. And there's the text value change function. Booms. And so if this is true, if we can find an isChange, and this isChange has the value change function, then we know that the process has changes. So now we can say order has changes. And else, I'm just going to make it simple because we don't want long values. So I'm just going to say no changes. Now we have actually defined an attribute on the process level. Now that we have these attributes defined, we can actually define our dimension. So I'm going to go here and into my dimensions. So I'm going to go onto my dimensions and I'm going to create a new dimension. I'm just going to add a create dimension, and this is going to be a single level dimension. That just means a basic text dimension. And always start by picking the attribute isChange. Use a calculation because we have a calculation. And single level dimensions can have an ID plus a descriptive value. And because we only have this one type of attribute, we don't need this description. So we can just get rid of this. And then I can up here call it isChange. And so now here up here, I need to change the description of the dimension. I'm just going to call it has changes. Now there's one more thing we need to do. We need to register this dimension at the process tree. So I'm going to register here the isChange dimension at the process tree. I'm going to save it. And now let me test if my dimension works. So what I'm going to do now here is activate the configuration. And if I press on activate the configuration of group processes, it will activate my attributes, my measures and dimension, and my process tree. So that's all I need. And now what I need to do, I need to recalculate the measures, because when I activate the configuration, the data is not actually being calculated, only the data structure of the database is being changed. So now when I recalculate the measures, the data will actually be calculated. And then I can check if my calculation works. Okay, and we're done. So let's look here and refresh. And you can see we have now a new dimension, and I can add this dimension. And we can see it works. All these orders have changes. And we can take a look at here. And we see number of changes 1. Number of changes 1 here. And we should also have the isChange function is a change function. And if we go through other functions, this is not a change function. So our dimension clearly works. Beautiful. Now there is something else I want to do. I want to also calculate the number of changes per process. So let's see how we can do that. Well, very simple. We already have the number of changes on the function level, but I want it on the process level. So now let me create yet another attribute. And I'm going to call it also number of changes. I'm going to use the same attribute. This time I'm actually going to use a default value, because if we don't get a sum here, and I'm going to be really lazy, and all I'm going to do here is sum up all the attributes values of number of changes. I'm just going to sum them up. And if I don't have any results, I'm going to leverage this default value right here. So now we have number of changes on the process, and I can go to measures, and I can define my number of changes measure here. I have here my number of changes, And notice I also earlier already created, and I didn't record this on the video, I created here a function measure for number of functions. I made it a num key indicator. So num key indicator means we can count the volume overall. And so here we can, on the process level, I want the average. So if I look at different process instances, I aggregate them together, I will see the average value. All right, so now we have our measure defined. On the dimension level, let's also leverage the attribute we have on the function level. So I'm also going to now define the function dimension. The function dimension is change here. And I'm going to use the calculation rule again. And I'm going to call it isChange/f/sf stands for function. And I'm going to make sure that this is a function dimension. And again, I'm going to save my results. And there's one more thing I have to do. I have to register everything at the process level. So here we have this new dimension isChange. I have to be in edit mode. And I also want to register, of course, my measures. Once I'm done with this, I'm going back to programs, going to activate my configuration. Now that I've recalculated my results, I can now check here my results, and you can see we now have more measures. I have number of changes here on my process level, and you can see we have 2 changes, 1 change, 1 change. But let's go back and actually look at some charts. It'll be a lot more fun with looking at this in charts. And I'm going to make this a little bit smaller. So if you don't have a 4K resolution like me, you can look at this as well. And so here, let us take a look at some dimensions first. So first of all, I want to see number of the change functions. So you can see we have, so the first thing I want to test is, does my function dimension work? And my function dimension here is the isChange function. Now I get the same amount of no changes and change function because I'm using number of processes, because every process has both change functions and no change functions. What I really want to see is, what about the number of functions? So this really shows me how many change functions do we have and how many no change functions do we have. So this is working fabulously. We can also here use the measure number of changes. And you can see here, I still have this little mistake here. I should correct that, but that's no problem. And you can see here the no changes, there are no changes, and all the changes come from the change function, and overall we have 6. And then of course we can go back and look at our number of processes, and we can look at all of the processes have changes. So if I really want to know if we have processes without changes here, the answer is no. All of our processes have changes. So this together just shows you how you can use calculation rules to build all kinds of custom calculation. These were very simple examples, but it shows you a little bit how the calculation works. Of course, you can make very complex things with this calculation tool. The key thing about it is that you don't need to code, but you can do pretty much anything a programming language can do for you. That's the whole idea of it. I hope you enjoyed it. Yeah, so this wraps up our video about metrics.